Hi, this is Ethan Nowaski with the Week 7 explainer video for Chapter 19, Question 19. The question asks, two cars collide head-on while each is traveling at 80 kilometers per hour. Suppose all their kinetic energy is transformed into thermal energy. What is the temperature increase of each car? You can assume that each car's specific heat is that of iron. So here's our diagram of our two little cars. We have car 1, and then we have car 2 of mass 1 and mass 2 that we don't know. Maybe they're the same, maybe they're different, but we have to consider them as individuals. So when we have our two systems like this and they're colliding, we have our total kinetic energy equation as 1/2 m1v squared plus our car 2 1/2 m2v squared, because the velocities are the same but we don't know what their masses are. Question also tells us that our kinetic energy is transferring totally and completely into our thermal energy. So what that means is we have our thermal energy equation that we want to consider when we are looking at the change of temperatures of a system, which is mc delta T, or mass times the conversion of how much energy it takes to convert a substance to heat it up, basically, times delta T. And so we can set our kinetic energy equation equal to that mc delta T. So we have our total kinetic energy equation and our total change in thermal energy equation. So we actually want to look at each the change in thermal energy of each car. So we have to also consider as M1 and M2. So we actually have our kinetic energy of car 1, which is 1/2 mv squared, and then our kinetic energy of car 2, 1/2 m2v squared, is kind of mirroring what we're going to do with our change in thermal energy equation, which is our m1 c delta t plus m2 c delta t, because we have to consider that the cars are also individuals and their change in temperatures are also going to be, their change in thermal energy is also going to be unique for their masses. But that actually helps us because we can factor out our M1 and our M1 plus M2 and our M1 plus M2 on both sides, and that allows us to divide them out, basically making the masses negligible, but you still want to consider them in case, just in case they don't. So that leaves us with our 1/2 v squared plus is equal to c delta t. Divide the c on the other side, you get it equal to delta t. And we know what our c is and we know what our v is. They tell us that the conversion for these two cars is just iron. So if we look into our textbook, that we see the conversion for iron when we're looking at masses is 449 joules per kilogram. And then we have our velocity is 80 kilometers per hour. And that the velocity converts to 22.22 meters per second. So we plug those values in. We have our 22.22 meters per second squared, meters per second all squared on top, and times all over our 2 times 449 joules over kilograms times Kelvin. And this gives us our delta T. We actually just solve this, and then we get our final temperature is 0.55 degrees Kelvin. And when we're looking at a delta T, we can just convert the Kelvin into Celsius, because that's the conversion for Kelvin and Celsius. You plus 273.15 for both of them. It's still the change is still the same of 0.55 degrees Celsius. So that's why we can actually convert that right there. And that's the answer to this question of how to convert this kinetic energy of these two cars colliding into this thermal energy and the change in temperature of each car. Thank you.